Let's see what you learned. All right, here we go. Remember, when you answer, you don't necessarily have to raise your hand, okay? I want you engaged, I want you answering. You can blurt out the answer if you like. But what I want to see is people who even aren't afraid to make a mistake to let me know what they think the answers are. So, if I gave you something like this, is it a monomial? No. Is it a polynomial?
Yes.
Yes, because it's more than how many? More than one. So a binomial we could say is a polynomial, but we normally call binomials for 2, trinomials for 3, and poly is 3 or more. Okay? With that being said, you learned a lot from what you were looking at, both through Quizlet and through Desmos. What is the leading, listen, what is the leading coefficient of what I wrote? Just say it out loud. 5. Okay, so the leading coefficient, you're telling me, is the number that is in front of the what? The biggest power, okay? So we have x to the 10th. X to the 10th does not have to be shown first. On your quiz, I want you to write it first. On your test, I want you to write it, and you can write this in your notes like some of you are doing. I want you to write it in descending degree order, okay? That's the simplified form. Now, if I asked you to tell me what degree is this polynomial, what would you say?
10.
Now listen, I'm going to change this up. Now, and I heard the questions that you guys were asking each other. And the discoveries that you chose to do. Okay, here we go. What's the leading coefficient? So I've heard 5, I've heard -1. No one has it yet. Listen.
12.
Okay.
-15.
So what were you going to say? -3, it's not -3.
-180.
Oh, there we go. Check it out. So we have a leading coefficient of -180. So team 6 gets it. Now listen. So yes, listen. The leading coefficient, guys, part of your group bonus points is please stop talking when I ask you. I need your attention certain times, okay? So, when you're multiplying, you must get all of these together and tell me what is the leading coefficient. So you must multiply everything, okay? Like Vishal did, he got -180 was your leading coefficient. And the reason of that is because you should interpret this as what? Blank. Say it, don't be afraid. A monomial or one term. All of that is one term because it's glued together with what? Multiplication. It's glued together with multiplication. If you will not remember that past 4 o'clock today, write it down. It's all glued together through multiplication, meaning it's all one monomial. These are separate islands. They're not all together. Why? Because they're separated with addition and subtraction signs, okay? Very important, okay? So now, what I want to do is, I want to look at this problem right here. So please go to your calendar, and on your calendar, you're going to click on the one that says cubic parent function, and it will show you this right here, and we're going to start this problem. This right here is different. This is different. And in your notes, in your paper notes, I kind of want you to label this as 2 things. Direct and inverse variation. So go ahead and write that down into your notes, okay? So we're going to put this is like its own category, direct/inverse variation. You did not do anything with warming up on this. This is new. All right. Who wants to volunteer to read this whole thing? Okay, go for it, Sophia.
Windfarms are a source of renewable energy around the world. The power per in kilowatts generated by a wind turbine varies directly as the cube of the wind speed V in meters per second. The picture shows the power output of one turbine at 1 wind speed. To the nearest kilowatt, how much power does this turbine generate at 10 amplitude s wind?
Okay, check it out. This right here, thank you. If you don't understand what that looks like, that's meters per second. Write that down in your notes if you don't. What would miles be? If M is meters, what's miles? MI. Write that down if you don't know it. What's MIN? Minutes. Write it down if you don't know it. Some people were struggling with that earlier, no worries. There's two words that Sophia that read that were the most important from that paragraph. What were the most important two words from that paragraph? Nice. Varies directly. So varies directly is going to say, that's very important because when I learned this stuff, I didn't pay attention to those two words. And when I looked at this, be honest, raise your hand. How many of you would try to use fractions that look like this from geometry, like proportions, to find this answer? Me too. I would have tried to use fractions in the past. I would have tried to find what is the pattern? What is the rise over run, or what relationship do they have? That's too much work. That's and sometimes, a lot of times it doesn't even work correctly. Okay? So here we go. Varies is very important. When you see varies, I want you to write equals K, or the way they wrote it in this example, equals A. You see varies, you're going to write equals K. If you see directly, guess what you're going to do? Wait, what?
Equal.
Not equal, not y over x. Good guesses, though. No worries, I don't expect you to know this. If you do, that's awesome. Directly, you're going to multiply. And this is the part that I was daydreaming when I was in your grade, and I'm not kidding. This exact concept, I didn't understand until later because I was daydreaming whenever it was mentioned. Directly is to multiply. What do you think the word would be for dividing? Not indirectly, that's what I thought too. Inversely, okay? Inversely. So go ahead and write inversely. This means to divide. Again, if you are saying answers and you're still wrong, I promise you, you're still going to help your team because you're engaged. Now, here we go. So I read varies directly, so what I'm going to put is equals K times something. Okay? You tell me, what should I put to the left of this equal sign right here as far as from reading that paragraph? The way Sophia read the paragraph, I should put P. Here we go. P varies directly. You see what I'm doing? I said varies, so it's equals A. I said directly, so it's multiplication. And what would I write at the very end? Come on. No one said it yet. Not just V. V cubed. Okay? So V cubed, this is my equation. I just created what I want you to write down in your notes as a general equation. This is an A, my bad. So this is an P is equal to A times V cubed. And this is your general equation. Now we've done, yes?
Would you rather us write A or K?
Okay, so here's what I'll say. Here's the thing. A or K doesn't matter as long as you understand what it represents. So write A. That's fine. Write A. And that's a good question, and that's good timing on this question too. Because if I'm looking at this, the reason why the author chose to use A is because you've recently learned this. You with me? What does A represent? Vertical stretches or compressions. So in here, it feels like a vertical stretch or compression. But the difference is that this letter is a constant. It will never change. Once you figure out what it is, it will always stay that constant. Okay? And it's a fancy word, proportionality constant. So those of us who would normally use proportions and fractions, this is where it comes from, but we've got to know how to set it up because it could be a difference between multiplication or division. Okay? So proportionality constant is A. So we have P is equal to A times V cubed. You've done general solutions before. They look like this. That's general. Okay? General, vague. It's still general. Can someone tell me why it's still general?
No exponent.
I don't think I heard it. Too many variables, but the most important variable that needs to change is B. Is B. Listen. Listen, that's what I'm showing you. You learned this in Algebra 1. This could be an equation. But it's not done until you write 3x plus something. 3x plus 0, 3x plus 10, 3x minus 5, right? Let's see if you remember. What is it that I need to give you to be able to solve for that B? Okay, touche. It could be a y-intercept or, I don't think I heard it, a point. A point. An x and y point. So if I gave you something like, let's say, 1, 4, you with me? 1 is x, so it's 3 times 1. So 3 plus b is equal to 4. Do you see how I did that? What's b? 1. So what I just did is I made this general form into a particular, more specific, more detailed, a particular equation that is known as 3x plus 1. This is now particular, and it's ready. I could give this equation any x, and what will it spit out? A y. You with me? I can't do that with this one yet, because I don't know. No worries, it'll come back. I don't know a, okay? I don't know a. I need to figure out a. So what do I need to give?
Separate it.
Say it out loud. I need a point. I need a P and I need a V. The P that we were given is 600 kilowatts. The V that we were given is 8. It's still multiplied with the proportionality constant of A. In our calculators, it's been a minute. Let's do the menu solve feature practice. Here we go. I want to do, someone show Donald at team 3 in case he hasn't seen this yet. I don't think he has. I want you to do the solve feature, and we're going to together solve for what is A, okay? If you don't know, if it's been a minute, just look up here. And we're going to do menu 3.1, which is algebra solve. And we're going to say, what? 600 equals A times 8 cubed. We're going to do comma A. Oops, not B. Because we want it to look for A. And please press Control Enter. I want to do the power. It's to the left of x squared, right here under equals. Okay? And I want you to round to 3 decimal places, okay? So A is 1.172. If you want to write 1.171 and truncate means not to round, but just to cut it off and leave it. That's fine too. So with me, here we go. I'm going to write A is 1.172. This is my proportionality constant that will never change. So I've created this general form to be more exact, to be 1.172 v cubed. This is my particular equation. It's ready. Okay? It's ready so that I will be able to answer this last question. I just have to do what from here? Plug in what? 10 for v. So plugging in 10 for v, 10 cubed is 1,000. That means we're going to move it 3 over to the right. This will become 1,172 kilowatts. That's the power that you get from that wind speed. It's easy, just steps to remember. Okay? It's not difficult. This isn't difficult math, just steps to remember. Okay? Alright, any questions before I move on?
Can you demonstrate the calculator again?
Yeah, so the calculator real quick, just to review. Menu 3.1, algebra solve, and then type in the equation exactly how you see it, comma A. Control Enter for decimal answers. Alright. Now, our next thing that I want you to pull up is this one right here, okay? The paper that you grabbed on your way in. We're going to look at cubic quartic functions, and at the end, we're going to look at what you discovered today with your groups. Okay, here we go. So, cubic functions. Be ready because I'm going to call on you, okay? I'm going to call on random people. Please be ready. Know what I just asked you, okay? Here we go. True or false? The first thing I have is a cubic function. Apurva. True or false? The domain is all real numbers. True or false?
True.
Hold on, Apurva. What's true? Now tell me why you said it's true. Okay, so here we go. Listen. This is what I'm talking about. This is the flip grid thing that I'm talking about. I want to hear how you know so you can develop that understanding. If you don't know it well right now, no worries. You will develop, I promise. But don't be afraid to tell me what you think it is, okay? I want to hear what it looks like and feels like and hears like and sounds like, smells like, everything in your brain the way you see it, okay? So, Purva, you said it's true and it is true. Tell me why you said true.
Because it extends to like infinity.
Okay, so it extends to infinity. Are you saying like this?
No, like
I see what you're saying. You're saying, okay, so she's developing. It extends to negative infinity and positive infinity on the x-axis. You see what I said? You see how clearly I said it? All x's are included. I bet you anything my next definition is going to be even better because of what you learned of how she answered that. And hers will even be better. Carter, true or false? The range is all real numbers.
True.
Why?
Because there's arrows at the end of the line, so it shows that it goes on the infinite distance of the y.
Perfect. Look at that. It's developing more and more. All y's are included in the range, okay? So I will highlight this, show this, and then, and again, your answers are going to be different. Someone can describe something totally different but still understand the same way. Vanya, true or false? No minimum or maximum values.
True.
True. Why?
Because
There's many different answers on this.
the range is all real numbers.
Okay, so the range is all real numbers. Not quite. I can't go off of that. No worries. I like the attempt though.
Is it because since there's not like an actual, like it goes through the origin, that there's no like minimum or maximum?
Okay, so do you hear? I want you to put all these together. We're going to build one together.
Well, so because at the middle where it goes through x equals 0, there's a line, and so there's no point where it's actually higher. One point's actually higher than all the others.
Okay, I'm going to let a couple more. We're developing closer.
There's no exact, the only really like point there is at the origin, and but like the line keeps going higher and higher and lower, so it's never gonna stop. So
I got
it's
you.
never maximum.
Carter?
Well, because the graph is infinite in both ways, and there's like no actual point where it stops. So like there's not like a higher or lower value.
He's the closest so far, but he's not done. I want it explained simply.
Minimum and maximum has to do with y values, primarily, and the range is infinite, so.
Almost, Ryan?
Since the range includes all real numbers, there's no complicated.
You guys, I see where you're doing, and I see the misconception. It is very close, and I like your point, but check this out.
There's no vertex. Right?
Okay, he's the closest now, okay? We went from Carter to now here.
There's no break in the line.
The break and the stop. Who said the stop? Someone said the stop. I think it was Carter. So, very, very close. Here, let me help you. It never changes direction. When you change direction, you create a max or a min. You with me? You create a max or a min, otherwise a vertex, whoever said the vertex. You see, otherwise the break or whatever it is, the stop. You understand? Please write that down in your notes if you need to. No min or max because it never changed direction. That's an important skill that you're learning in this unit. You're learning how to graph without using the graphing calculator, without using Desmos. And I'm talking about things that look difficult, but they're not. Okay? Here we go. X-intercept and y-intercept is at the origin. The origin is 0, 0. If I told you to tell me what is the x-intercept, you would say x equals what? 0. if I told you to tell me the y-intercept, you would say what? Y equals 0. If you tell me a point, you need to know what you're talking about. Do you understand? Look, the x-intercept is that one. You with me? The y-intercept is that one. If you say that the y-intercept is all of this, you would be wrong. Do you understand? Because the x and the y, right here, and this is for bonus points, they describe two different things. What do you think they describe?
Two different axes.
Nope.
That's what I was gonna say.
Okay, here we go. I'll help you out. The x is where. Okay, write that down. The y is what? Or what is the value? Okay? Where or when is x. What that value is 10. You with me? Alright, so for instance, I'm going to create a quick function. So my 10-year-old was with me over the break. He introduced me to Fortnite. Okay? I'm not even kidding. And yes, I am a big-time noob default, but no worries. D represents days. What do you think 8 represents? The number of, no, not the number of days. Number of hours per day we played. So, we played a lot of video games, and I got better at Fortnite, by the way. So, 8 hours, we played for about 4 or 5 days. I want to say 5 days. Check this out. It has to do with this. We played 5 days. I just wrote f of 5. Can someone tell me, does f of 5 mean this or that?
This.
It means, f of 5 means y. So listen, and you're not the only one. A lot of people have the misconception that f of 5, listen, is the result of playing 5 hours. So if I created a point, this would be like 5 f of 5. If I played for 5 days, right? What would be the amount that I actually played? 40. So f of 5 is 40. Do you understand? That's important, guys, because the notation that's coming your way, you have to understand the input and output. Okay? Hold on just a bit. Here we go. If I drew a graph and I plotted 1, 2, and the function's f of x, you could say, instead of 2, you with me? Instead of 2, I could say that the max equals f of 1. I know that's a little weird and it's a little unsettling for some of you, but when I see f of 1, it's the same as looking at 2. Because f of 1 is the y value when the x is 1. So when the x is 1, the y value is 2. That's a big O. Because the where and the what value is what we're trying to show. And there's a lot of that in calculus. A lot. Okay? So I want you to understand that early on. So here we go. When x increases, here we go, y increases. Is that true? Yeah.
So that little part in the middle where it kind of like slides over, is that a flat line or is it still increasing?
Okay, so yeah, that's a calculus-based question. Okay, so it is not a flat line; it is still increasing at the origin. Very, very important. In fact, the reason why I'm giving him 200 points is because that question is argued over and over again amongst calc teachers every single year as far as what is actually happening there at that instant. Now, that's a big question. That is a huge question. That is a huge question that he just asked. Okay? So here's what I'll say. For now, just know this. It's increasing throughout. It doesn't have a horizontal line yet. Okay? So it's just increasing throughout. Watch my highlights. Not in my hair because I don't have hair. X decreases, right? When X decreases, Y decreases. True? True. As X decreases, as you go to the left, so here we go. When X decreases, aka go left. Okay? When X increases, aka what?
Go right.
No, go right. Okay? So go right. So the second part is Y says goes up and down. We good? Okay. Here we go. The function that I'm looking at right now that I just introduced to you, a new function. Let's see your memory for bonus points. We've looked at several functions this year. What's one of them? Quadratic. Square. Absolute value.
Absolutely disgusting after this.
Linear. So we've looked at this graph, we've looked at this graph, and we've looked at this graph. These are all defaults, okay? So yes, I got my own little account and whatever, and yes, I have no skins whatsoever, but I'm trying to get them. As far as I'm a default, I'm basic, noob level, no skins, no nothing, no extra whatever, right? So this is me, okay? My son is an extension transformation of me, and some of him looks like me. And the sum of him that looks like me is right there. But he's got all this extra stuff. He's got all these extra skins and whatnot that, yes, he read up $1,200 on my credit card not too long ago. Anyway, my point is, but I got every penny back. I'll tell you that on a different story because we're losing time. All right, my first transformation, I got every penny back, every penny.
Did he keep the $50?
Yeah. Oh, okay, real quick. All right, man. No, I don't want. All right, here we go. Transformations wise, here we go. This is something new. This is something new. The first one is this -2. So it is a horizontal shift 2 to the right. Okay, here we go. Let's catch up. I did give you that show, but we have to catch up a little bit. The second one is this 2, which is a what?
Vertical shift upward.
Yeah, vertical shift 2 up. So now I'm going to take my default basic 1, 1, -1, -1, and 0, 0 x cubed function. This is me. And I'm going to transform this into my son. Okay? So my son is this one right here. Everything is shifted 2 to the right and 2 up. Okay? So this one that's at 1, 1, this is important, guys. This is huge. Watch very carefully because you'll see this on your homework too. 1, 1 is going to be shifted 2 to the right and 2 up. If I do left and right, what value am I affecting? X. If I do up and down, I'm affecting what? Y. Here we go. So 0, 0, -1, -1, and 1, 1 will change to this. The first change, 2 to the right. Notice what happened.
No, it didn't.
I added 2 to the x value. Now shift up 2 units. So 1, 1 is now going to turn to 3, 3. Do you see it? 0, 0 will change to 2, 0 because you moved 2 to the right. And then it'll go 2 up, which is y value, to 2, 2.
So is that how you get it to where?
This is how you're going to do it this unit. You're not going to be able to use a calculator. You're going to have to do points by points, and these specific points are called pivot points, okay? So -1, -1, if I moved it 2 to the right, I would have this. Check my math. And if I move it 2 up, I would have this. So that my new transformation, which is my son, looks like this. That's pretty easy. I want you to understand what's going on here because it can get more involved depending if they're vertical stretches, compressions, and so on and so forth. Alright, so here we go. for the sake of time, I'm going to just list the transformations and remind you the order that we need to know them by. And I'll let you do what I just did on your own for like homework extension, okay? Here we go. The first one, and I'm going to show you, and I'm going to tell you because we're running out of time a little bit. Remember the order is B, C, A, D. Okay? So it's a horizontal shift 1 to the left. Okay? Next one is a negative. Not negative 2, just the negative. Is a reflection or reflects across the x-axis.
Where's that A?
This is like negative 2, the whole thing is A. Okay? So this part right here, 2, is a vertical what? Stretch by 2. So vertical stretch by a factor of 2. Nice? And last but not least, yep, vertical shift. Well, almost messed that up. 1 down. I added the up. Okay. So vertical shift 1 unit down. So I want you to look at the points on your own. I want you to graph those at home and so on and so forth. We're not done, guys. Stay with me. Do not slow down because I wasted a little bit too much time with that story. Let's turn the page over to the quartic one. And the quartic one looks like the following. Okay, so the quartic one, again, all we're going to do is list out the transformations. I want you to do the drawings and stuff, and you can watch the video if you need to, of what you would do going forward with the graphs. Here we go. The first transformation is a horizontal shift
To the right.
3 to the right. The negative is a reflection across the x-axis again. The 1/2, help me out, vertical, because it's not inside with x, is a vertical compression by 1/2. Yeah, vertical compression by 1/2. Now look, here's a key that I'm going to help you, and I'm recording this. Anytime it's horizontal, it's the x value. Remember the way that I was showing you with those points? Anytime with the vertical reflection, or you know what I'm saying, is going to be the y value. A vertical is the y value. Okay, please don't put up yet. The fourth and final one is a vertical shift 2 down. Again, this would be y value that you're going to multiply, oh sorry, not multiply. You're going to subtract the y value by 2. Look here. You're going to multiply the y value by 1/2. Right here. You're going to multiply the y value by what?
1/2.
Negative. By negative. And here, you're going to add the x value with what? 3. Okay? Here we go. Last one. And then we have that last page. Yes, we have about 8.5 minutes left. It is enough to finish, okay? So this fourth one right here, this fourth graph, it says 2x to the 4th plus 1. Your first transformation is a horizontal compression by 1/2. Careful on the Pearson homework because it's a little bit weird, okay? But play around with it and figure it out, please. Horizontal compression by 1/2. And then, yep, vertical shift 1 up. Now, your last page of notes. It goes pretty fast. You've already discovered this a lot already. Here we go. Your last page of notes looks like the following. You have even, odd, plus, minus, and it looks something like this.
Yep.
Okay, here we go. When your degree is even, that means when the power is like 2, 4, 6, 8, anything even, something's going to happen, okay? And I'll show you that in just a bit. There's a lot happening in the next 3 minutes, so please watch. Let's say that we had y is equal to, and our leading coefficient was positive. Let's say positive 3. And this one will say negative 3. A lot is about to happen. Please watch. Here we go. The way you're going to graph this is you're going to look at the leading coefficient. That means the number in front of the biggest power of x. If it's positive, then as you go to the right, or go right, it's going to go up. It's going to go positive. You with me? Because this is even, as you go left, it also is going to go up. So there's a nice kind of symmetry going on. Notice the color coordinating that I'm doing. The most changes of direction that you can have is that number minus 1. So 2 minus 1 is 1. That means you have, please don't put up, 1 change of direction. And that makes sense. This is what this graph is going to look like. Now it'll develop. I already see light bulbs going off and you're understanding already. Now, again, if I looked at this number, which is the leading coefficient, and it was negative, that means as I go to the right, we're going to work all the way to the bell, so please stay with me. As we go to the right, it's going to do what? It's going to go down. Okay? Here we go. Watch the steps, because these are easy to miss. If it's an even number, what's going to the left going to do? It's also going to go down. Okay? 1 less than this, 2 minus 1 is 1, says that it could have a possible 1 change of direction. These are these words that we were saying earlier whenever we were trying to discover it together. Now let's say that it's an odd power, okay? So it's an odd degree. Here we go. We could say a positive 4x cubed and a negative 4x cubed. Y is equal to, please watch the steps. First, and you will have a quiz over this soon, because it's a positive leading coefficient, as I go to the right, it's going to go up. Because it's an odd number, if I go to the left, what do you think it's going to do? It's going to go down. Okay, this is odd. Okay? Because this is 3 minus 1, there's possible 2 changes of direction. Possible 2 changes of direction. The graph will look like that. You with me? And then over here, the only difference is that it's going to go down as you go to the right. Everything else is the same. Okay? Now, I heard this earlier in one person that I'm going to award points right now that I remember hearing them, is that Ethan said x to the 4th is like x squared, but it's only fatter on the bottom. Look at this. This is important. If I have x to the 4th, some of you are probably looking at this and saying, shouldn't we have 3 changes of direction? But here's the thing. You don't have to have 3 changes of direction. You could have up to 3 changes of direction, but guess what else you would need in order to show the possible other changes of direction? You would need more than just x to the 4th. Do you understand? There would have to be more things involved for them just to have 1 change of direction. Okay? These are a multiplicity of roots. Please flip the page over. I'm well aware that we have about 43 seconds. Here we go. Multiplicity of 1. Stay with me all the way to the bell. This has a multiplicity of 2. This has a multiplicity of 3. They're all occurring at 1. Okay? If it's 1, it's just going to go through. If it's 2, it will bounce. And if it's 3, 5, 7, 9, anything odd that's not 1, it will squiggle through. And we are done. Nicely done, guys. Nice.